STP. STP or Spanning Tree Protocol. In this video I'm going to talk about one of the most important and most famous and most useful protocols in the LAN. We call it STP. First we should know about the function of the STP. After that we can learn about the tuning of the STP and also some part of configuration about the STP. Let me to start talking about the STP with this scenario. In this scenario, as you can see, we have three switches, switch 1, switch 2 and switch 3, and also three PCs, PC1, PC2 and PC3. I added one link between the switch 2 and switch 3 for redundancy. Let me to remove this link. If you don't have this link, when the for example link between switch 1 and switch 2 failed, okay, this means that we don't have connectivity between the computer 2 and computer 3 and computer 1. Or if this link, for example the link between switch 1 and switch 3 is failed, this means that we don't have connectivity between the computer 3, computer 2 and computer 1. Because of that, it's a good practice and it is useful that having one link between the switch 2 and switch 3 for redundancy. Because of that, as you can see now, we have one link. This is the link that we are adding for redundancy and for fault tolerance. Okay, the reason that we are using this extra link is for fault tolerance. For example, assume that with this link, now I am removing this link, failed, assume that this is failed, and after that, because we have the link between switch 2 and switch 3, we can send traffic from this link from the computer 2 to computer 3 or computer 1. Or if the link between the switch 1 and switch 3 is failed, we can send traffic from the computer 3 with this link to the computer 2 or computer 1. Because of that, it's a good practice for that we add one link between the switch 2 and switch 3. Very good. This is the good side of the for example adding one link, but here we have one bad side effect. Let me to talk about this bad side effect. Because of that, we should follow a packet from, for example, computer 2. After that we can understand what is the bad side of the adding one link. Look at here. First I'm trying to send a traffic from the computer 2 to the computer 3. You know that the source MAC of this packet is MAC2. Let me write here M2 means MAC2, and destination MAC of this frame is MAC3. Okay, this frame now is receiving by switch 2. You know that in each switch we have a MAC address table. Let me to show you MAC address table. In MAC address table actually we have 4 fields, but let me to use only 2 of the most important fields, the MAC address, okay, and after that the for example port. And you saw the MAC address table and you know about the detail of the MAC address table. Okay, this is the MAC address table of the, for example, switch 2. Let me to write here MAC address table of the switch 2. Okay, and the MAC address table by default is empty. Because of that, when we are receiving this frame, first we should learn the MAC address of the for example M2 means MAC2 on the port 3. Okay, let me to write here. Now we have one entry here, and that is the M2 means MAC of PC2 on the port, for example 3. We can use fast Ethernet 03. Okay, after that, because we receive one unknown unicast frame, you know that this MAC address M3 is not available in the MAC address table of switch 2. Because of that, this is an unknown unicast. Unknown unicast frame should be flooded. Because of that, we should flood this frame to the switch 1 and also to the switch 3. You learn about the rules. When we are receiving unknown unicast frame, we should flood. It means we should advertising or forwarding this frame from all of the other ports except the incoming interface. Because of that, now this frame is received by switch 2. First the source MAC is learned on the fast Ethernet 03 and then flooded. Let me to follow one of them first. Now I'm going to follow the this frame from the M2 to M3, and now this is received in the switch 1. In switch 1, again, we have the similar MAC address table. This is the MAC address table of switch 1. Okay, here when we are receiving a frame from the MAC2, we should learn it on the port 1. As you can see, this frame is receiving on the port 1 of switch 1, and because of that we are learning the MAC2 on the fast Ethernet 01. Again, we should flood this frame because this is the unknown unicast frame. Now this frame is flooded from the fast Ethernet 01 from the switch 1 to the switch 3, and also here we have another frame. Let me to show you from the switch 1 to the over the fast Ethernet 03. This is the source MAC. Source MAC is the MAC2. Destination MAC is the MAC3. Okay, you know that because the computer 1 doesn't need to this frame because the destination MAC is not equal with the MAC address of the computer 1. This frame now is dropping here, and the computer 1 does not accept it. This means that the frame here is dropped. Okay, after that, this frame from the M2 to M3 now is receiving by switch 3. Again, we have the same story. In switch 3, we have one MAC address table, then this is the MAC address of table of switch 3. The source MAC, MAC2 is learning by switch 3 on port 1. Okay, MAC2 is learning on the port 1, and then the switch 3 also should flood this frame. This frame now is flooded to the computer 3, okay, and also to the switch 2. And after that, the computer 3 should accept this frame because the destination MAC is MAC3, the MAC of the PC3. It's good. Okay. After that, we have now another, for example, frame. This frame again should be received. Let me to change the color of the other frame. Okay, look at here. This frame is receiving by the switch 2. Now the switch 2 should change the source MAC of MAC2, okay, to the fast Ethernet 02. You know that we can't use one MAC address on multiple interface. Because of that, in switch 2, you know that first we learned the MAC2 on the port 3. Now we can see the MAC2 on the port 2. Because of that, the MAC2 now is residing in the port 2, and this entry should be changed in the MAC address table of the PC2. And now, as you can see here, we have a problem. The problem is that the MAC2, okay, is residing in the wrong port. You know that the computer 2 or MAC2 is residing on the port 3, but we are learning the MAC2 on another port. This means that if switch 2 receiving one traffic to destination of MAC2 means PC2, that traffic should be forwarded over the fast Ethernet 02, and this is not correct. Why? Because the MAC2 is residing on the port 3. Okay, this is the first problem. After that, you know that again we should flood this frame. For example, when we are receiving the frame to destination of MAC3, again in MAC address table of switch 2, we don't have this entry. We need to flood it to the computer 2. Okay, and also again to the for example switch 1. This means that when you are advertising a frame, you will receive the same frame, and this is not normal. Why? Because when we are advertising or sending a frame, we expect to this frame is receiving to the, or for example the destination, not again to us. Because of here we have a problem. Let me to write here, this is not correct, and this is one of the problems. Very good. After that, you know that here we had two frames. The first frame is this frame, and you know that this frame again should be advertised to the switch 1, again the same procedure. But let me to talk about the second frame. You know that when the computer 2 sent traffic to the switch 2, we forwarded this frame to the switch 1 and also to switch 3. This is the switch 3's frame. As you can see now, the frame with the source MAC of MAC2 and destination MAC of MAC3 is receiving by the switch 3. Again, switch 3 now is learning the MAC2 on port 2 here, and it should change change the MAC2 from the fast Ethernet 01 to the fast Ethernet 0, for example, 2. Okay, this means that now the MAC address, the MAC2 is changed in the MAC address table of the switch 3. And then because switch 3 doesn't have any information about the MAC3, it should flood the frame to the port 3 and also to the port, for example, 1. Let me to show you. This is the same frame.